Okay, so this is going to be a video for the study guide for section 2.4 and 2.7, and I'm going to work out every single problem on the study guide with my voice to assist you and colors to make it all nice and pretty. Anyway, so here we go. I'm going to start, so I'm going to, study guide SG 2.4, 2.5. I'm going to start with number 1, and this is assuming that you either paid attention in class or you watched my videos at least, so for the individual sections 2.4 and 2.5, that way you're at least a bit familiar. This video is not meant to teach you the concepts from scratch, so bear that in mind if I'm going a little too fast, because I'm assuming you know at least a little bit about the sections here. So 12 over 15 times 10 over 14. Well, I can multiply them across like this and then simplify, but I'm going to simplify first and then multiply because usually that's the base case scenario. And I go with the breakdown method because that's the most complete way to simplify. There's no better way. So I'm going to break down the 12 fully. 12 is 2 times 6, and 6 is 2 times 3. So I can write the 12 as 2 times 2 times 3. That's 6, 12. On the bottom here I have 15, 5 times 3 or 3 times 5. The 10 is 5 times 2 or 2 times 5. 14 is 7 times 2 or 2 times 7. Now that everything is fully broken down, I can't break anything down any further. Prime, 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 everything else is prime. I start to cancel, my favorite part here. I find any ordered pairs that are the same in numerator and denominator, and I cancel them out. I have a 2 here, I have a 2 here. I have another 2 here, but no more 2's down here. I have a 3 here, I have a 3 here. I have a 5 here, I have a 5 here. I have another 2 here, but no 2's down here. I have a 7 here, no 7's up there. So what I'm left with, at the top is a 2, another 2, here and here. On the bottom is a 7. That's 4 over 7. Fully simplified. I expect you to have this answer, not 12 over 21 or any other combination as such, because those are not fully simplified. This is as simplified as you can get. Number 2. And number 2, it's a pretty similar problem, except I threw in that negative in there, because I like to throw in negatives. A negative kind of person. Anyways, the way I work with the negative is I put the negative outside and then I break down the 16, and I'll worry about the negative later. So 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's why there are 4 4's there. Fully broken down. So I prefer that you don't write just 2 times 8 and leave it as such. Fully break down the 8 into the 4 and the 4 into the whatever. The 20 is 5 times 4, and 4 I can write down as 2 times 2. Again, fully broken down. The 12 is 2 times 6, and I can write the 6 as 2 times 3. 14, 2 times 7. Not much I can do there. Alright, so now they're fully broken down. I am going to go on my crossing rampage, finding the same number in the numerator and denominator. Gone. 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 Oh, that's it? 3, no 3's. 2 2's, but no 2's. Oh, okay, that's it. So what I'm left with is this negative. Then at the top I have 2 times 2 times 2 times 3. And I think, yeah, that's right. So 2 times 2 times 2 times 3. The negative is still there. On the bottom I have 5 times 7. 2 times 2 is 4. times 2 is 8, times 3 is 24, so negative 24. 5 times 7 is 35. And that is my answer for number 2. Moving on. I can pause this, I guess, if you want me to stop. So, three. All right, 9 over 10 times a negative 20. Yep. The only trick here is, besides the negative, which we dealt with in the last problem, is the 20 is not a fraction, but I can write it as a fraction. I could write 20 like this, over 1. Now they look similar-ish. Then I'm going to do my breakdowns. The 9, I can break it down into 3 times 3. The 10, 2 times 5. The negative on a pull out here, the 20 is 5 times 4, and the 4 I can write down as 2 times 2. Oops. Parenthesis, yes. And the 1 is, well, a 1. Alrighty. Now, cancel time. 2 and 2. No 3s. 5 and 5. Yay. And that's it, because there's nothing left on the bottom. So I don't have to look because there's only 1 left, and, well, 1's a 1. So on the top I have 3 times 3. I still have that negative outside, so I'm going to just keep it outside. Times 2. On the bottom I have a 1. 3 times 3 is 9. 9 times 8 is 18. There is still that negative over 1. So yeah, that's it. That's the answer. Moving on to 4. Oh, and do realize that any problem that's on the study guide could end up on the quiz. Very likely that problems like, think of this as like version C of the quiz, with few extra problems thrown in. So, yeah. The first thing I want to do with this problem is convert my mixed numbers into non-mixed numbers. 3 times 3 is 9, 9 times 2 is 18, and that negative is still there. Pesky negative. 2 times 22 is 44. 44 plus 3 is 47. Then I'm going to go ahead and break things down. The 18, I can break that down into the negative outside. 9, which is 3 times 3, and then times 2, so it's 3 times 3 times 2. 9 times 2. 47, I can't really break that down into anything. It's going to stay at 47. It's a prime number. Kind of unfortunate how that happened. Kind of angry now. Anyways, because I made these problems myself, so. 3 down here. The 22, I can break that down into 2 times 11. Boo. Anyways, canceling, I can cancel this out, that's it. Not much else. I'm going to make my own problem, so I should probably make it so I can cancel more things, huh? You would think. Anyways, negative here. Inside I have the 3 times 47. Did I do this right? 18. Yeah. Yeah, I guess I did. It's not a nice problem. On the bottom, I just still have 11. 3 times 47, that's 3 times 40, which is 120. 3 times 7 is 21. So 141 negative over 11. And of course, you can convert that into a proper fraction. I'm not going to. You don't have to either. That, if I did my work correctly, I'm kind of questioning that, but I'm going to move on because I'm kind of tired. Moving on to 5. Five is a slightly different type of problem. 1.2 multiplied by negative 3.9. Alrighty. When you multiply decimals, a slightly different set of rules follows. You could always convert them to fractions and multiply them that way. That's actually a pretty valid strategy, to be honest, at least for some of them. because that could be 1 and 2/10, and that could be 3 and 9/10. Let me shut my door. I'll be right back. Pausing this video. And I'm back. Sorry about that. Alrighty. But I'm gonna do the traditional way that we deal with multiplication problems. I'm gonna check to see how many numbers I have after the decimal in each of my participants. Here I have one number after the decimal. Here I have one number after decimal, which means I have two numbers total after the decimal. Now that I've established this, I've written this down somewhere. What I'm going to do next is I'm going to pretend the decimals do not exist. 12 times negative 39. Next, I'm going to figure out what the sign of my answer should be. Positive times negative, it should be negative. Then, I'm going to do my long multiplication without decimals and without signs. 9 times 2 is 18. Write the 8, save the 1. 9 times 1 is 9, plus that. 108, 6, 3, 8, 6, 4. So my answer is negative because positive times negative is negative. 468. Now how many numbers did I have after the decimal in the original problem? 2, which means I need to move my decimal over twice. So my final answer is a negative 4.68. And that's that for that problem. Well done, Mr. B. Number 6. Negative 0.32 times negative 2.17. We're going to do the same thing we did for the last problem. Figure out how many numbers are after the decimal. 1, 2, 1, 2. Total 4. 2 plus 2. Then I'm going to write them out as if the decimals didn't even exist. Negative 32 times a negative 217. The sign of my answer, negative times negative, positive. Then I'm going to do my long multiplication, ignoring both the sign and the decimal. And I know you guys are not going to like me for this because I'm going to stack my 217 on the bottom. You probably want to stack it on the top. Works out the same way, so I don't really mind. 7 times 2 is 14, 4 here, 1 in reserve. 7 times 3 is 21, I had 1 in reserve, 22. 1 times 2 is 2, 1 times 3 is 3, 2 times 2 is 4, 2 times 3 is 6, 4, 4, 9, 6. So my answer is 6, 9, 4, 4. Now, how many numbers did I have after the decimal? I had 4, which means I need to bring back my decimal 4 places. 1, 2, 3, 4, right there. Which means my final answer is 0. Positive, of course, 6944. Not too bad. Not saying it's the easiest way to do this, but it's a safe and reliable way that just works every single time. So yes, safe and reliable. All right, next up we have problem number 7. Alrighty, 7. Here we go. Let's see here. Division. So on the back, starting with 7, on the front were all the 2.4 section problems. On the back are all the 2.5 section problems. So I kind of split them up very nicely for you, because I'm nice like that. So we have division of two rational numbers, in this case fractions. Now we don't have any good rules for division of rational numbers, but we have some decent rules for multiplication. So what we do is we turn the division into multiplication. But we can't just do that without some consequences. And the consequence in this case is we have to multiply by the reciprocal. What is the reciprocal? Sorry, we have to multiply by the reciprocal of the second number. The second number is called a divisor. The first is a dividend. So we have to multiply by the reciprocal of this, or the multiplicative inverse. And what is the multiplicative inverse of this? That. So I multiplied by this. Another way of thinking about it is you take your divisor, the second number, and you flip it. I like that method, but the book says multiply by the reciprocal, and that's what they mean. You multiply it by the number that will make the product of these two a 1. Confused yet? Good. Now I'm going to do my simple multiplication because I know how to do this. Can't break down the 2, can't break down the 3. I can break down the 9 though into 3 times 3. The 8 I can break it down into 2 times 2 times 2. Hopefully you know why that's 2 times 2 times 2 by now. Ooh. Cancel time. That's it. Left on the top is a 3. Left on the bottom is 2 times 2, which is 4. And that's all that's left. Yay. Next up, problem number 8. Very similar to 7, except I threw that negative in there to, I don't know. It's just there. Same thing, I'm going to turn this into multiplication by either multiplying this by its reciprocal or flipping it, whichever way you like. I'm going to go with the flip. It flips out and turns into this. Yay. Now I'm going to break things down. Negative 5. The 10 is 5 times 2. The 20 is 5 times 4, and the 4 is 2 times 2. 15 is 5 times 3. Time to cancel. Hey, red, don't fall. Okay. 5 with 5. 5 with 5. 2 with 2. That's it. So on the top, I'm left with the 2 from the top, the 3 from the bottom, and do not forget the negative. There we go. Well done, Mr. B. I'm now going to pat myself on the back. 1 second. Okay, done patting myself on the back. Negative 21 over 22 divided by 2 negatives. Scary. 15 over 33. Looks like an interesting problem. Promising, promising. Maybe lots of cancellations. Change the division to a multiplication by flipping this guy out. The negative doesn't really matter where it goes, top, bottom, middle. Negative is a floater. So multiply that by a negative 33 over 15. Then I am going to, because I can, and I will, break things down. Negative outside, 21 is 3 times 7. 22 is 2 times 11. Times, I'm going to choose the negative to be up top. Doesn't really matter what it is. So up top, negative here. The 33 is 3 times 11. 15 is 3 times 5. I could have brought the negative down here. Doesn't really matter. All I know is that it's a negative times a negative, so my answer is going to be positive. So I don't have to worry about that. Yay. Cancel time. Less than what I hoped for, but I'll take it. 3 with the 3 here. Or I could have done, who cares. 11 with the 11. That's it. Nothing else I can cancel. As I told you earlier, negative times negative is positive, regardless of where that negative was. 2 negatives anywhere in the multiplication problem. On the top I have 7 times 3, this guy and this guy. On the bottom I have 2 times 5. this guy and this guy. And that nets me a very cool 21 over 10, which you can of course write it down as a 2 1/10, maybe. I don't care. I like this better, but you can do that. I know it's not a proper fraction. I don't mind them. I don't actually like mixed numbers. But yeah, 3 more. Almost there, give or take. Number 10. And yes, I'm doing this after school, so you guys are at home, and I'm tired and doing this for you. For you. All right, first things first, I'm going to put this over 1. And I'm going to change this from a mixed number to a non-mixed number. 2 times 5 is 10, plus 2 is 12. And if I make any mistakes, I apologize. You can point them out to me during class again, because I am getting kind of tired. All right. Next, I'm going to convert the multiplication the division into multiplication. See? Tired. Which means I have to flip the 6 over 1. I'm just going to write it in the same color.
Alex?
Sorry about that. Announcements. Yes, where were we? Flipping the 6 over 1 into 1 over 6. Then I'm going to break things down. The 12 becomes 3 times 2 times 2. That's 4. 4 times 3 is 12. The 5 can't break that down into anything. The 1 is a 1, and the 6 becomes 2 times 3. 3 with 3, 2 with 2. Cancel time is over. On the top I have 2 times 1, which is 2. On the bottom I just have a 5, and that's my answer. Technically I didn't have to multiply anything. So I started with a division problem. I ended up with a multiplication problem, which I didn't even multiply anything in. Sweet. 11 is next. Let's see if I can squeeze all the last few problems. Nope, I'm not going to be able to. Maybe. I don't know. We'll see. All right. 0.95 divided by 0.25. Oop. And yes, division with decimal numbers. This is different. And the normal rules don't apply, because I don't want to switch this to multiplication, because if I do, look what happens. Times, if I flip that, I get 1 over, yeah, that's really not any bad. That's actually worse. That looks worse. So, no. Say no to that. Instead, we have a different set of rules for division. And this is what we do. Just like multiplication, I'm going to convert these to whole numbers. Unlike multiplication, I don't have to worry about changing my answer. Why? Look at it this way. If I have 4 divided by 2, that's 2. If I have 40 divided by 20, that's 2. 400 divided by 200, that's 2. 4,000 divided by 2,000, that's 2. You get the idea. I can go on for infinity. So here I multiplied both top and bottom by 10, multiply top and bottom by 100, multiply top and bottom by 4,000. My answer didn't change. Well, that tells you that in division, I can multiply both numbers by anything that I want, as long as it's the same thing, and I'm good. I'm safe. It's kind of like with equations. I can multiply both sides or add or divide both sides by whatever I want. In division, I can multiply both sides by whatever I want. As long as it's the same number, I'm good to go. So how can I get rid of the decimal numbers? What can I multiply them by to get rid of them? Well, since I am 2 decimal spaces short of a whole number, I'm going to go ahead and multiply both of them by 100. When I multiply both of them by 100, it allows me to move the decimal space twice. 1, 2, 1, 2. And I don't have to worry about it in my answer. So I'm just going to be dividing 95 and 25. And that's it. That's it. And you know how to do this. This is long division not a problem. That's going to be 3, 20, doesn't fit, 200, and that is 8? Yes. So the answer is 3.8. Simple. So in division problems with decimals, you simply want to get them both to be whole numbers. And you multiply them by whatever you need to get there, as long as it's the same number by both sides. In this case, multiplying it by 100 got me where I needed to be. And usually you'll multiply by 10, 100,000, 10,000, or a derivative of 10 to get where you want to be. And I'm going to do 12, the last problem, and then I am done. Yes. All right, so negative 0.264 divided by negative 1, 2. All right, so once again, how can I get, first of all, I have a negative divided by a positive. I know my answer is going to be negative at the very end. So that being said, I'm ignoring signs now. I know my answer has to be negative. That's good enough for me now. So I don't have to worry about signs anymore. Second, I want them both to be whole numbers. What do I multiply a 0.264 for it to become a whole number? I need to move the decimal 3 times, which means I need to multiply it by 1,000. And while I don't need to multiply this by 1,000 to get it to a whole number, I have to, because I have to do the same thing to both numbers. When I multiply by 1,000, it's the same thing as having my decimal move 3 places. Here it's going to move 3 places too. And I'm going to add that 0. So at the end, what I have is 264 divided by 120. Again, I'm ignoring the sign because I already figured out my answer has to be negative. So then you do your long division. Goes in there twice. 24. Doesn't go in decimal. Twice. So my answer is negative 2.2. Done. Alright, if you have any questions, ask me tomorrow in class. I am kind of tired, so I'm just going to sign off, upload this to YouTube so you have it available at home for those of you who actually will check this out at home and do the homework, because this is homework if you don't finish this in class. I'm going to go around tomorrow, give positives to those who did it, negatives to those who didn't, yada yada. Anyways, bye-bye.